Hi everyone, my name is Tatiana Gimmelstein and I will be talking about Chapter 6 of Well Played Building Mathematical Thinking through Number Games and Puzzles. This chapter will be on mixed operations and we'll be talking a little bit about the different games and puzzles throughout this chapter. Let's start off by saying a few things. One of the things that kids miss out on in school is the ample amount of playing time. And playing time is mostly reserved after lunch, and it's usually just the 15 minutes of running around in the schoolyard. It's very rare that you see playing done in the classrooms, specifically for math. Games are not always seen as educational, but they are, in so many regards. In math, games allow students to practice and hone in on those key concepts that they have been learning in the classroom. If anything, students are more engaged and they're learning more from gameplay than from their teachers teaching them the concepts through simple instruction and just problem solving. Games get students to think about their next moves, coming up with different strategies, also working as a team or a group to win. The games that I will discuss in this video are on mixed operations, basically using the different symbols of arithmetic, addition, subtraction, multiplication, and division in gameplay. These games further investigate the relationships among operations and numbers. Sense-making activities such as these games will help students experience mathematics for real. By looking at relationships, patterns, and making generalizations, students can build bridges between arithmetic and algebraic thinking, while still deepening their conceptual understanding and strengthening their procedural skills. Just giving students a rule to solve different types of problems isn't enough. The rules need to be developed in conjunction with their experiences with those types of problems for students to get the real gist of what they're learning. Before further ado, let's talk about these great games that will help students better understand and be more immersed in gameplay using mixed operations. The first game that's mentioned in this chapter is Roll 6. The goal of this game is to use the numbers and rolls in a table to find the product and then use the products to write expressions equal to the numbers. The numbers 1, 2, 3, 4, 5, and 6. Students essentially practice multiplication and factorization in this game. The game encourages students to use the products to come up with the different equations through the use of order of operations. Students have to work through trials of what numbers can be used to give a specific number given what information is there. Students tend to only incorporate addition and subtraction when coming up with solutions, and I think that this game will encourage students to use not only addition and subtraction, but different kinds of operations and in different orders. The second game that's mentioned is Write It Right. Yes, I said this right. This game is like Sudoku, in that one must only use the numbers 0 through 9 only once. Students need to focus on the relationships and patterns in the puzzle in order to place the numbers 0 through 9 in the correct places, and to make the statements true. Players are exposed to different operations in this fill-in-the-box exploration activity. One can do this in groups or individually. There are also different ways to modify the puzzle board into simpler numbers 0 through 6 and the original 0 through 9. The main challenge is where to start on this puzzle, which equation to solve first, in order to then solve the others given. This takes a good sense of the relationships and the operations when dealing with numbers. However, students tend to persevere in figuring it out on their own. The third game, Decade Roll. Most of us have been drilled to memorize PEMDAS, and we've used Please Excuse My Dear Aunt Sally in elementary, and then again in middle school. Although it was helpful when we had to solve problems with multiple operations, there were many misconceptions about which operations came before others, instead of learning them in terms of pairs. Also, there is this super important can never forget rule. you have to solve from left to right, or you will most likely get the wrong computation. Students are still learning PEMDAS, and they're also playing games such as this to reinforce the concepts. In this game, any of the 4 operations can be used in order to come up with a number that fits into any of the decades. Students can create single, 2-digit, or 3-digit numbers. Using the numbers, they roll with the 4 dice. They can use at least one operation, or they can use this one operation many times. Or they can just switch it around and use all 4 different operations, addition, subtraction, multiplication, and division, to compute, and then figure out which decade they can place their results. In order to meet this activity with success, one must be able to understand and use relational thinking to interpret and communicate the convention of the order of operations accurately. This game is also a test in mental arithmetic abilities, which makes it more fun for the higher grades and older students and maybe even adults. There are decimal points in this game that create a great challenge, if need challenge. The next game is called Calculator Target. It's often that students want to take the shortcut in math and ask for a calculator to solve a problem. However, it's not that kind of game here. Instead, the goal is to complete expressions to meet or get as close as possible to the target numbers. The team with the smallest differences or points for each round wins. The idea is to use the target number that is created by 3 cards being flipped over. This is the same number that's used for both teams. Teams switch recording sheets to write an operation and a number to the right of the operation, and this number has to be less than the target. Without using calculators, each team quickly has to write a number to the left of the operation. Calculators are then used only to compute the equations, and then the difference is found between the target number and the calculated result to tell who's going to win that round. This is a great challenge for students to learn the concepts of estimation, mental math to estimate, operations, and accuracy. And the last game, Contig, I hope I'm saying this right, I'm not sure. Here, students are rolling 3 dice, using order of operations to compute, and see if they have a result that is on the board, similar to bingo. If they do this, and they get a number that's on the board, they put an X on the number to get 1 point, and an extra point for any other number that is marked and touching this initial number that you have an X on. However, there is competition in this game. If one team cannot make an expression for the numbers that they rolled, and they couldn't figure out an operation that will result in having a number that's on the board, then it's another team, their opposing team, that is able to figure out the expression to use. And if they have the number that's on the board, they win the point. But interestingly enough, they don't have to mark it on their board. It's a race to see who is an expert in expression making using the order of operations and quick mental math. There are also other games online and different apps on the phones that students can use to work on order of operations. But I think these 5 games in this chapter are a little more hands-on. They offer multi-dimensional thinking and strategy solving. And I think it's something that's more engaging for the students, as opposed to just clicking something on a keyboard or on their phones. Well, thank you for listening, and I'll see you next time.